Hello there, and welcome to this video where we're going to be looking at the representation of data in computer systems from the OCR Computing specification, and in particular in this video we're going to be looking at different numbers. So OCR say that you need to be able to convert from denary numbers 0 to 255 into 8-bit binary, add two 8-bit binary integers together and explain overflow errors, convert positive numbers into 2-digit hex and vice versa, convert binary into hex, and explain the use of hex to represent binary numbers. So converting a positive number into 8-bit and vice versa. First thing you can always do is create a binary table, which I've got on the screen there, and that gives you the layout of what you need to do. We're going to be looking at the number 56 in this example. So first we'll look at the left hand column, 128. Is that going to be sortable for 56? No, it's not, because 56 is smaller than 128, so we move to the next column. And then we've got 64. 64, that's not going to be any use. So then we go along to 32. That 32 is going to be useful for us because we can fit 32 into 56, and then you just keep working all the way through along the line to be able to come up with your binary number. Similarly, if you get given an 8-bit binary number, create this table. So for example, if you had 1 0 0 0 0 0 0 1, put that into the table and then just add the numbers above in the table to be able to work out what the number is. Adding two 8-bit binary integers and explain overflow errors which may occur. The main part about this is that you need to remember your basic binary addition. So 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0, carrying the 1. So for example, if you're going to add 10 and 11 together, that's going to give you 22, and when you write it out, it's nice, easy and straightforward. Same thing in maths when you have to carry a digit over. So for example, if we had 90 plus 13, you would carry the 1 over to be able to create it into a hundreds number. Exactly the same setup here. Overflow errors occur when there's not enough room to show the data. So for example, if we're looking at this 4-bit binary problem here, we've got 1111 plus 0110. That's not going to fit as a 4-bit binary number, because what we're saying is we want to have 8 plus 4, which is going to be 12, plus 2, 13, 14, plus 15. So we're saying 15 plus 6, which is going to be 21. And that wouldn't fit for a 4-bit binary number. Similarly, if you had an 8-bit binary number, it would ask you, you'd need to use a 9th bit to go on the end, and that is where the overflow error comes into play. Converting positive and denary numbers into whole numbers into 2 hex decimals and vice versa is easy as pie. The way you do it is you convert it from denary into binary and then binary into hex. So we've got this example here that 122 in binary is 0, 1 1 1 1 0 1 0. Chop it in half, so you've got two groups of 4, and we can say that 0 1 1 1 is equal to 7 for the first part, and then the second part 1 0 1 0 is equal to 10. 7 in hex is 7, 10 in hex is A. Put the two together, then we've got 7A. 122 in hex is 7A. And finally, we're going to be looking at explaining the use of hexadecimal numbers to represent binary. So binary numbers can be used, take up to 8 bits of data. So for example, 0 1 1 1 1 1 0 1 0. It takes a lot of time. It takes a lot of storage space. If we can make it small, if we can abbreviate it, if we can convert it into a different system, so I use 2 characters, for an example 7A, it's going to save a lot of storage space. It's going to increase processing time. If you have a large series of instructions, say over 30 to 40 lines, and you've got to go through 8 bits for each instruction, it's going to take the machine a long time to process, whereas if it's going to be converted and written in hex, it's a lot easier to quickly write and understand. Also for the computer, it means it's got less brain work to do because it can actually get to work a lot quicker. I hope this video has been helpful for you. Feel free to like, comment and subscribe, and I'll see you in another video.